So guys, in our last class, we have discussed one of the technique for exploratory data analysis, which was handling missing, how to handle missing records or none values in a data frame. So we used mean, median and mode to take care of that situation. So we simply use a replace function to replace nan value with the mean, median or mode of that particular column. Apart from this, we have two other functions, which is bfill and ffill, in case you want to fill missing with their backward record or the forward record. So we can use bfill and ffill for that, but I do not use a lot that function. In case you want to do that, so you can use bfill and ffill as well. So now we are going to explore another option of exploratory data analysis, which is handling duplicate values, or to find the duplicate value and to remove those within that data frame. So this is also important in case we have a lot of duplicacy in our data frame, so it doesn't make any sense to create a model using a duplicate value. So we are going to apply this on our car data set. So the name of our data frame was car_df. So we are going to check the duplicacy of our data frame. So let me type the name of our data frame, which is car_df, and I want to check the duplicate values. So I'll be using a duplicated function for that. So using this function, what I'll get Boolean output. In case the data is duplicate, then I'll get output as true. In case there is no duplicacy, I'll get output as false. So what I'm going to do, I'm going to store all the duplicate value into a duplicate object, and I want to count that how many duplicate records are there in my data set. So I'll be using a print function for that, duplicate, in which I have stored the duplicated values, and I'm going to apply sum for adding all the duplicate records here. So you see that there are total 14 duplicate records available in car_df data frame. So now let's say you want to check what are those duplicate records. In case you want to see those duplicate records, so we have that option too. So the syntax to do that would be the name of your data frame, which is car_df, and within the index parenthesis you will be writing duplicate, the object where you have stored those duplicated values. So using this, you will get all the duplicacy available in your data set. So you see total 14 records are there, and all are duplicates. If you give it a look, you see that all the duplicate rows, all records are duplicate here. So I need to remove those. How I'll be doing that? First, I'll be writing the name of the data frame, which is car_df dot drop underscore duplicates. This is a function which is used to drop the duplicate values, but we are using in place keyword here, because by default in place equals to false is already set into this. So to handle this, I'll be using in place equals to true in case I want to make changes to my data. And let me store this. Let me call my function this data frame again, car_df, and I need to check again that whether I have removed those duplicates or not. So again I'll try the duplicated function here, duplicated, so that I can check test duplicate. Let me give this a name as test duplicate. So I need to get confirmation whether I have removed all the duplicates or not. So let me print this, print test underscore duplicate. So here you see, in case you want to apply, all false values would be there. So let me use the sum function so that I can count all the duplicates. and you see here is 0. Means now in your data frame, after applying drop duplicates in place equals to true, there is no duplicacy in your data. So just you have to be sure. So again you try to check that in case might be you missed to apply in place equals to true, so that we don't make changes to our master data. So whenever you are going to make changes to the master data, so we recommend to use in place equals to true. Means actually you want to make changes to the data frame. That's why I have used in place equals to true. So you see you have removed all the duplicates. Let me go through with the code once again. What we did first, we check the duplicated value in our data frame. That was the name of our data frame. Duplicated is a function to check all the duplicacy in our data. We have stored that into duplicate. You can give any name to this. I have just used duplicate. Whatever name you want to give, you can. It's not a fixed keyword. Then I have simply sum those duplicate records so that I can change what number of duplicates records are available in my data set. So these are 14. And then I have checked what are the duplicate values. So to do that, I have simply exported that part. So car underscore df into the index parenthesis, I have passed that duplicate value which is already stored using duplicated function. And then I have applied drop duplicates to drop the duplicacy in our data frame and with in place true. And then again to test that whether we have removed duplicates or not, we have again applied duplicated function to the data frame and then store to the test underscore duplicate and then sum up the duplicacy, and we found 0. So in case you want to check the shape of our data frame now, because earlier the shape of data frame was 303 and 13, means total 303 index was there, rows were there, and 13 columns. So now let me check the shape of my data after removing the duplicacy, and you see 289 rows are there. So after removing, in case you minus 303 minus total 14 records, so you see 289 is there because 14 was the duplicacy, 14 rows were duplicate, so we remove them. Now our data is get shorted, so all duplicacy has been removed. I believe it's clear to you how to remove the duplicacy from a data frame. Now we are going to talk a bit about the bivariate analysis. Bivariate analysis basically is to analyze two columns altogether or to understand the relation between two columns. In case we have multiple columns in our data frame and we need to check the relation between each and other columns, and let's say in case we found good relations, so we will fetch those records and we'll further using those records. So we have multiple visualization techniques to get that. In case you are applying bivariate analysis basically is for two columns. So these two columns can be numerical as well. When we have both numeric columns, so the visualization techniques that we are going to use will be scatter plot, line plot, heat map for correlation, and joint plot. For two numeric columns, in bivariate analysis, we use these plottings. In case we have one categorical and one numeric column, then we'll be using bar chart, Boolean plot, categorical box plot, swarm plot. These are certain predefined plots that we recommend to use in case we have categorical and numerical data and we want to apply bivariate analysis. And then in case we have both variable as categorical variable, then we can apply bar chart, group bar chart, and point plot, so that we can get a clear picture that how these two variables are connected to each other or related to each other, and what are the relation between these two variables. So bivariate analysis is basically to understand the relation of two variables, and these two variables can be categorical as well, can be numerical as well. So I have given you the options in case both are numerical, so we will be plotting these, and in case one is categorical, one is numerical, so these are the best option to do the bivariate analysis. And in case both are categorical, we can use bar chart, group bar chart, and point plot. I'll be coming up with some exploratory data analysis part, that how to use these plots for doing bivariate analysis with a different data set, or might be we can apply this on this data set as well. So I'll come up with the next video for the bivariate analysis. So that's it, guys. Fine, keep learning, keep exploring new things, and don't forget to write in a comment box either you like the videos or not, or in case you need, in case you have some suggestions, or you want me to create some videos based on a particular topic. So fine, guys, thank you, take care.